Hello everyone and welcome back to exercise number 56 of the SolidWorks basic tutorial series. In this video, we're going to be designing a stepped hose adapter. Now, as always, in designing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extrude boss base feature and extrude cut feature, but also, if you study the geometry very carefully, you'll notice that to create the 3D body, the easiest way would be to use the revolve boss base tool, and that is exactly what we're going to be doing in this exercise. Here we see the schematic drawing for exercise number 56. All dimensions are millimeters. We have two isometric views and we have a section view. And the section view showcases the internal details of the component. We have the front view and we have another section view showcasing the internal dimensions, all right? And this section view was taken along this plane, this cutting plane, section AA. All right, so in creating this part, of course, we need to answer the question, what is the mass of this part in grams? And we're following the millimeters, grams, and seconds unit system, all right? So that is the unit system that we're going to follow. As for the material, we're going to be assigning material of ABS plastic. So this part here, this hose adapter, will be plastic. All right, so how are we going to model this within SolidWorks? And I think the easiest way to create this would be to sketch out half the contour of the front plane that we see here, all right, using the line tool. And then we're going to assign all the necessary dimensions. You can find the dimensions either on this front view or this section view, but for the most part, most dimensions are going to be found in the front view. And then after that, we're going to use the revolve boss base tool to create the 3D body, the main 3D body. Subsequently, we're going to use the extrude cut tool to create the opening here. If we look closely, we have a stepped opening. The first opening has a diameter of 11 millimeters, followed by a cut depth of 10. And then we have another opening with a diameter of 5.1, and then the opening goes all the way through the component. Please take note here that we have a chamfer. We have three chamfers. We have the chamfer right here. That's 1, 2, and 3. And we see here that the dimension for the chamfer is 0.5 by 45 degrees. That is the angle and that is the distance and angle convention. But also we could use the distance convention since it's 45 degrees. So either way, either it's the vertical dimension or the horizontal dimension is going to be 0.5. And of course, the chamfer is going to be added at the very end. So in creating the 2D sketch, we're going to ignore any chamfers that we have, all right? And then just use the revolve boss base tool and then add any necessary details at the very end using the 3D features. So that is our game plan, and it's a very simple part within SolidWorks. Yeah, so with that aside, let's get started with exercise number 56. Okay, so to start, let's go ahead and create a new SolidWorks part. Let's set the background to plain white, and let's go ahead and copy exercise number 6 into SolidWorks. All right, so let's just make this smaller. Again, this is a very, very, very small component of about 4 centimeters across from one end to the next. So it's expected that the final weight for the component is going to be in the grams, so it's very, very light. All right. So before we actually model this component, let me just show you something here. I've took it upon myself to show you what certain hose connectors look like, hose adapters. So if we do a simple Google search, we see that we have many different variations of the adapter, hose adapters. But for the sake of our tutorial, we have a stepped hose adapter. So in this case, it looks something like this. Okay, so we have these grooves that prevent the hose that we're connecting to from sliding from the adapter itself. All right, so again, this schematic drawing was taken from an actual component that I have lying around at home. All right, so again, sorry for the slight detour, but it was something that I thought I might share with you. Anyway, so again, to remind you, our first step, or the easiest way to create this, would be to sketch out the 2D profile and then use the revolve boss base tool. Okay, so to start, let's select the front plane, sketch. Let's drag this upwards, and what I'm going to do is very simply, again, sketch the contour that we see here using the line tool. And as for our origin, it's going to be right here. All right, so just drag this closer. activate the line tool, and from this point, let's go ahead and draw contour. That's 1, 2, 3, 4, all the way to the bottom here. Then we have another horizontal line, another one just slightly vertically downwards. All right, and then what do we have? We have a line here that goes, let me just make sure, okay, yeah, okay, that goes like this. And then, again, this is just me creating the contour here. Oh, and then close off the figure. All right, so that is the best approximation that I can create for the 2D profile. All right, so then we're just going to apply the dimensions. And we begin by the largest dimension that we have for the component, and that is 40 millimeters from one end to the next. So the distance from this end to this end is 40 millimeters. All right. Okay, so the dimension here for this line is 1 millimeter. Just follow the instructions, the dimensions that we have here, guys. All right. We have this as 12. This right here should be 3 millimeters. All right. From this end to this point, it should be 8, and it should be 8 likewise from this here. So this is also 8, and this is also 8, since, you know, it's just a repeating pattern. Okay, so what else do we have? We have a diameter here, largest diameter of 18. So this should be 18 divided by 2, which gives us 9. All right, and what else do we have? We see that we have, look at the section view here. We have from this edge to this edge is 16.1. All right, so this is 16.1 divided by 2. All right, and from this edge to this edge is 5. We're not going to stop until the sketch here is fully defined. That's when we know that we have all the dimensions needed for the revolve process. All right, so for this edge right here, it's 7.3. So this is 7.3 divided by 2. All right, and likewise, this is also 7.3 divided by 2, which is 3.65. Same thing here. From this point to this point, 3.65. All right, so what else do we have? We have from one extreme to the next, where the stepped section is 9.5. So from this point all the way to the center line, it's 9.5 divided by 2, which is 4.75. And just repeat the process right here. Okay, so this is 4.75. And same thing here, 4.75. All right. Now, if we look closely here, all the entities and all the lines are in black. And we have a comment here at the bottom that says fully defined. So the sketch that we created now is fully defined. Now we just press the S key, revolve boss base. For the axis of revolution, go ahead and select this line here, and then click OK. And that creates the main body for the component. Again, see how easy it was using the revolve boss base tool. Now, if we look at the section view, we have a stepped opening. All right. We can either sketch out the 2D profile of half of it and then use the revolve cut tool, or we can follow the more intuitive approach, and that would be to sketch out the circle and then use the extrude cut tool twice. So I'm going to use the second method. Just click on this surface, sketch, activate the line tool, and from this point, draw a circle, smart dimension, and the diameter of this circle should be 11 millimeters. Press the S key, extrude cut. The cut depth that we need, it should be 10 millimeters, all right? So the end condition now is set to through all both directions. So very simply just right-click on your mouse, select blind, and by default, the extrusion depth is 10 millimeters. So then just click OK. Now just click on this surface, sketch, activate the circle tool, and from this point, draw a circle, smart dimension, and we see that we have a hole here of 5.1 millimeters, diameter of 5.1. So this is 5.1, and press the S key, right click on your mouse, through all both directions, and then OK. All right, so that creates the opening for the component. If we take the section view, we can very clearly see that what we see here for the component corresponds to the section view that we see within the schematic drawing. All right, so let's deactivate that. Now, one last thing to do is we need to add chamfers. We have 3 chamfers. We have 1, 2, and 3, and each chamfer has a dimension of 0.5 by 45 degrees. So just press the S key, chamfer, enter a dimension of 0.5 millimeters, and assign the edges that have chamfered. You have 1, 2, and 3. And then click OK. All right, so that finishes, or that concludes the modeling process. So go ahead and delete this image. Assign a material, right click, edit material. Go down to the bottom, select plastics, and then select ABS plastic, apply, close. We can assign a color. It's up to you. I'm just going to select the first color that I see here. Okay. Now for the moment of truth, go to the Evaluate tab, Mass Properties, and we have a final answer of 2.75 grams. Our final weight is 2.75 grams. That is the mass for the component. Again, this component is very small. It's about 4 centimeters across from one end to the next. It's a hose adapter. It's going to be light, and it's made of ABS plastic, okay, kind of plastic. So the answer here is very reasonable. Okay, so that concludes exercise number 56. I hope you all enjoyed this video. If you have any comments or questions, please leave them down in the comment section below. Also, please don't forget to subscribe and support the channel for more content like this. I hope to see you all in exercise number 57. Until we meet again, bye-bye.